So now that we've looked at how to approach 3D Pythagoras examples, let's have a go at this example. So pause the video and have a go on your own. And now let's go through the solution. So for the rectangular solid below, find the following. Part A is the surface area of the solid. Now to find the surface area of any solid, we just need to add up the areas of all the faces. So this first face is a rectangle on our left-hand side, and we can see that it has dimensions of 2 by 10. 2 by 10 means we have 20 units squared. That's going to be the exact same as this face over here. So altogether, we have 40 units squared. Units just means because we don't have the units, we don't know if it's centimeters or meters or whatever. So I'm just letting it be units squared. So we've been given 40 units squared from these two black faces. Now, these two red faces I'm drawing here are the back face and the front face. They are also going to have the exact same surface area. Now, if I was to just draw that out, you can see the dimensions of the red face is going to be 7, so a length of 7 and a height of 2. And so that gives us 14. Now, since there's 2 of them, that means we're going to get 28 units squared from the red faces. And finally, when we add up the top face, it might be a bit difficult to see, but hopefully you can appreciate that there's a top face here, and there's also a bottom face at the bottom. In fact, it might be useful if I just erase the other ones and just show you like that. You can see there's a green face at the bottom, and there's also a green face at the top. The dimensions of those green faces are going to be fairly similar to each other. So we have 7 as our length, and then we have a width of 10, which gives us an area of 70. And since there's 2 of these faces, that means we're going to get 140 units squared. So that would be our green faces. So to get our final answer, the surface area of the solid, we just add the black faces plus the red faces plus the green faces, which is going to be 40 plus 140 plus 28. And that gives us a total of 208 units squared. So part A really didn't have anything to do with Pythagoras, but now looking at part B, we need to find the length of the diagonal AB. So how do we do that? Well, we can use the formula we derived from the previous example, and that was just the square root of all of the sides squared. So that would be 10 squared plus 7 squared plus 2 squared, and that would give us an answer of a square root of 100 plus 49 plus 4, which gives us square root of 153, and that will work. But let's just go through the question using our first principles on how we actually derive the formula in the first place. So we want to split it up into 2 right angle triangles. So this is the hypotenuse of a triangle I'm drawing just now. So that would be 1 right angle triangle, and I'll just draw that out. I'll draw it out over here. So this would be B, this would be A, and this right here is a hypotenuse of another triangle, which I'm going to draw out in green. You can see that this shape here is also a right angle triangle because the base is a rectangle, which means it's a right angle. And so this face here, sorry, this side here is going to correspond. So this one here is going to correspond to this one here. Now we do have the dimensions of these sides. We know that this side here is going to correspond to our 10, and we know that this side here is going to correspond to our 7. So using basic Pythagoras, we can say that this side here will just be the square root of 10 squared plus 7 squared, which is equal to the square root of 149. So remember, this side is equal to this side. So we can write that over here. Now we do also know the height of our rectangular prism, and that's going to be 2. So now we can find the length of AB by using Pythagoras again. So we can say that AB is equal to the square root of the first thing squared. So that's going to be 2 squared plus the square of root 149. Now we know that squaring and square rooting are opposite. And so when we square a square root, the square root basically disappears. So we're just left with 149. And so that's going to give us the square root of 4 plus 149. and that's going to give us a square root of 153. And that would be our final answer. Make sure to write units if they haven't given us the units. So we would just write square root of 153 units. So now let's move on to a harder example. Now, before we even attempt this example, I just need to give you a couple of quick pointers because it is a bit ambiguous on our diagram. So we know that AB is given as 5. We know that AD is given as 3. And we know that EB is given as 2. Now, the reason why EB is equal to 2 is because CB is 4. And since CE and EB are both equal, then that means we can say EB is equal to just half of 4, which is 2. So now that you've got this information, have a go at the question. So pause the video, and then we'll go through the solution now. So let's just have a quick read through what the question's asking us. In the diagram, triangle ABC and triangle DBC are isosceles triangles with AB equal to AC and DB equal to DC. AE and DE are perpendicular bisectors of triangle ABC and DBC, so that angle AEB, so angle AEB is this one here, angle AEB is 90 degrees, and so is angle DEB. So angle DEB, which is on the floor a bit, so I might just draw that in a different color. You can see on the floor, angle DEB is also 90. It looks a bit bad on the diagram right now, but I will draw out the triangles separately. We also said AB is equal to AC, so AB is equal to AC, and we know that DB is equal to DC. So that's really our annotated diagram from just using all the information here. So we need to find what AE is, DE, and DB. So a really good triangle that we can look at, which has both AE and DE in it, is triangle ADE, right? So if we just draw the triangle AED, so that would be AD, and this would be E, you can see that this triangle here, that's what we're looking at, clearly has a right angle here. So that's a right angle. We know that AD is 3, and we need to figure out what AE and DE is. So we'll leave it blank for now. The next thing we want to look at is another triangle that has DB in it. Now, where is DB? Well, you can see DB is here. Now, there's 2 triangles that are important to us to find DB. The first one is triangle ADB. Okay, so the triangle ADB, that's this one over here. That has the side length of 5 for AB, has a side length of 3 for AD, and using Pythagorean triads, the 3, 4, 5 triad, refer to our triad video if you haven't already, DB is equal to 4. If you haven't watched the triad video, you can also just use normal Pythagoras to figure this out, but obviously triads does make the process quite quick. So we've said that DB is equal to 4. Now, what other triangle, right-angled triangle to be specific, has DB in it? Well, you can see it's the slanted triangle on the base. It's going to be triangle DEB. So I'm just going to draw that out. So that's going to be triangle DEB, and this is a right angle because it's said in the question. You can see that's this triangle over here if I'm just tracing it out. Now, DB we've just found out to be 4. I said EB was equal to 2. Now, using our Pythagorean statement, we can figure out what DE is. So we can say that 4 squared, because that's the hypotenuse, is equal to DE squared. So we'll just say DE squared plus 2 squared, because that's first short side squared plus second short side squared. So 4 squared is 16, which is equal to DE squared plus 4. So we move the 4 to the other side, so it becomes a minus 4. So 16 minus 4 is 12, and that becomes DE squared. And so that means DE is equal to the square root of 12. We're just square rooting both sides. So now that we know DE is root 12, we come back to this triangle here. So we've got DE is root 12. So we've checked off DB. It's equal to 4. We know that DE is equal to root 12. And we also need to figure out what AE is. Now, AE is just the hypotenuse of this triangle ADE. So we can say that now we'll just move over here. AE is equal to the square root of the first thing squared, so 3 squared, plus the second thing squared, which is going to be root 12 squared. Now remember, when we square a root, it just undoes the root. So it's going to be just 12. And so we're going to end up with 9 plus 12. And so AE is equal to square root of 21. Now, the question does say that we need our answers in 2 decimal places. So for DB, we just keep it as 4.00 if we have to write 2 decimal places. So root 12 would be 3.46, and AE, which is equal to root 21, is going to be 4.58. So that would be our final answer. So hopefully you are able to see how we can use the theory for 3D Pythagoras for some actual concrete examples. In our next video, we'll be covering 10 homework questions. So make sure to attempt that video and then refer to the solutions when you want to go through it. So yeah, we'll see you there.